Hi everyone, welcome. We're gonna work today into the Calculus Early Trascendentals 8th edition. We're gonna work into the diagnostic test trigonometry. So let's go for it. So first, the first question is just to convert from degrees to radians. So the first one, we have 300 degrees. So we already know that pi pi is just like 180 degrees. So then we can proceed in that way. So if pi is exactly equal to 180 degrees, then what should be the value for 300 degrees? So we just multiply 300 times p over 180. So then we just like simplify 0 with 0. So we have 30 over 18, and then 30 over 6 is 5, and 18 over 6 is 3. So at the end, we came up with 5p over 3. The B1 is minus 18 degrees, so we proceed in the same way. So we already know the p is equal to 180 degrees. So then what should be the value for minus 18 degrees? We'll just like multiply minus 18 times p over 180. We simplified by 2, so we got 9 on 90 by 9, 1 over 10. So the answer should be minus p over 10. Second, we need to convert from radians to degrees. So we already know that p is equal to 180 degrees. So we just multiply. So then we have 180 over 6 is 30. 30 times 5, we have 150. Then the b part, we just have 2. We don't have any p. So when you don't have any p, you know that the 1 radian is exactly to 57.296 degrees. So just multiply that by 2, and you got the answer into degrees. Number 3. Find the length of an arc of a circle with radius 12 centimeter if the arc subtends a central angle of 30 degrees. So you need to go to the formula. The arc is equal to theta, or this theta times radius. The theta is already in radian, so well, actually you can take as well into degrees as we have. That's fine. 30 times 12, so we have 360 centimeters. Then if you want to convert that into the radian, so you already know the p is equal to 180. So it means like 360 is exactly equal to 2 times p centimeter. 4. Find the exact value of the tangent. So you already know that the tangent is 100. You replace p by 180 over 3. So then this should be this one. How do you know that? Well, I guess that with any calculator, for example, I have this one. So then you just put here something like tangent of 60 degrees. It gets should be better to write here tangent, and automatically Google brings here to the calculator 1.73. You need to say here degrees because otherwise it will bring something into radians. Okay, the next one, it says about the sine of 7p. So 7p, 7 times 180 over 6. So we have 180 over 6 is 30. So then you have 210, and then just again go Google it and you get it, and to the calculator you get that number. The second, exactly the same, just replace p by 180, then over 3, you have 60 times 5, we have like 300, secant of 300, you get 2. 5, express the length a and b in the figure in terms of theta. So you have like the hypotenuse is 24, you have A and B as the sides of this triangle. So then you can go with to the sin of theta is exactly to the opposite side, which is A, over hypotenuse, which is 24. So then just like replace or just like solve for A. 24 is dividing, go to the other side, multiplying. The cos of theta is exactly equal to the adjacent, so that's wrong. It's not A, it's B. So then you have cosine times 24 is equal to B. Number 6, if sin is x is equal to 1/3 and sec y is equal to 5/4, where x and y lie between 0 and P2, evaluate sin parentheses x plus y. So by the properties of the trigonometric identities, so you should visualize that the second is exactly the same as like the opposite of the reciprocal. The other side can complement for the cosine. So if you have second is equal 5/4, then the cosine is equal to 4/5. So then you have the sin. So you already know that the sin is exactly equal to the opposite side over hypotenuse. So you already have these two numbers. So you know by Pythagoras, the Pythagoras that you have like the opposite square plus adjacent square is equal to hypotenuse square. So just replace that by the adjacent, which is adjacent square equal to hypotenuse square minus opposite square. You already have the hypotenuse, which is 3. You already know the opposite, which is 1. So then you have 8. So then the square root of 8 is the value of A. Then because of that, the cos, remember the cosine is exactly equal to the adjacent over hypotenuse. So it should be square root of 8/3. So then you have to know because of the identities of trigonometric equations that sin parentheses x plus y is exactly equal to sin x times cos y plus sin y times cos x. So you already know that we already have most of them, but still missing the part of the sin y. So we're gonna find out kind of the way that we did before. So the cos y is equal to 4/5. So it means that the 4 is the adjacent, the 5 is the hypotenuse. So then you have O square O like square times A square equal to hypotenuse. So just like isolate or solve by O, which is the opposite. So then here you have by the opposite, you have the 4 is the adjacent, 5 is the hypotenuse. So then just replace. So you have at the end of the day 9, the square root of 9 is equal to 3. Then you already have all of the values, right? So because you already know that the sin of y is exactly the opposite side, which is 3/5, which is the hypotenuse. Okay, then here just replace. We already have sin x cos y, sin y cos x. So we just replace. Sin x is exactly the same as 1/3. The other one times 4/5 plus 3/5 times square root of 8/3. Just multiply. Remember that you multiply that parallelly. So then 5 times 3 is 15. 4 times 1, 4. And then 3 times square root of 8/15. Because it's like harmonious, like, or common denominator, so you can take out the 15 just like to become the expression a little bit more friendly. So then here you have this one. This is wrong. This is not plus. I'm so sorry. You have 1/15 times 4 plus 3 times square root of 8. So then here, this is the answer that we had. I guess it's not wrong. However, you should be aware that it's different from the book. So how you can become that the same as the book? Just like remember square root of 8, you can decompose that number, which is 2 square times 2, so the 2 squared, because of root properties, you can take it out. So then at the end of the day, the answer is this one. Remember again, watch out, this is not correct, this plus, because I'm just like collecting, but I did that wrong. So it's 1 over 15 times 4 plus 6 times square root of 2. Then we need to prove this identity. So we have that the tan theta times sin theta plus cosine theta is equal to the secant theta. So you can manipulate the left part of the right part, whatever you want. I want to work into the left part. I think it's kind of easier. So then I need to put that in terms first into the sin and cosine. So tangent is exactly equal to sin over cos, and then times sin plus cos equal to secant. Then, just like collecting this, the common denominator is cosine. So then cosine, here the sin times sin is like sin square plus cos square. So because of the identity properties of trigonometric properties, you know that this is exactly to 1. And then you already know that the secant of theta is exactly equal to 1 cosine. Next one. So I started working with the left part. So then I said, okay, I already know that the tangent is exactly equal to sin over cos. So I already took it out to make a little bit clearer about it. Times, we already know about the identities of trigonometrics, that 1 plus tangent square x, it's equal to 1 secant square x. After that, you already know that the 1 over secant 2x is exactly equal to cosine square. Then you can cancel one cosine because one is squared, the other is not, so you can cancel it out. So then you have 2 sin times cos x equals sin. Okay, exactly. Then we need to find all the values of x such that sin 2x is equal to sin x in the interval from 0 to 2p. 2p, remember, is 360. So we already know that those are like the same, but we already know that it's sin 2x, we can express that as 2 sin times cos, and then you can just like make them equal. After making them equal, like you can put sin to the other side, like subtracting. Then you can just like collect for sin x. So then you have sin x times 2 cosine x minus 1. So you have two possibilities. Sin x is equal to 0. So you need to put into the calculator which are the numbers that you can get at x, and the answer is 0. Which angle? You will see that is 0, p, and 2p. This is like some standard graph for sin. So you know that into 0, into p and 2p, this function is exactly equal to 0. And then from the other side, you have cosine equal to 1 over 2. So then after having a look for that, you know that the cosine, if you have the table, when it gets the value of 0.5, it's gonna be into p over 3 and 5p over 3. So then it means like just like joining both answers, the complete answer is the one that we have here. And the last but not least, the sketch graph of the function y equal 1 plus z into x. So then you have this one, which is the first the sin, okay, the standard sin, and then the sin 2, it gets like a little bit more compact, so it's like twice, it gets like closer, so you have like the sin 2x exactly equal to this. And then at the end of the day, if you just like put that one up, you have the value 1 plus sin 2x. Okay, I hope it has worked. If you have any other question, any lesson, just like don't hesitate to contact me back. And that's it. Thank you so much for watching my videos. Hopefully this is useful for you. Have a good one. See you next time. Bye bye.